Monica Pesce, and I'm associate partner at VVA Consulting. We are working on GNSS since 2009, and we decided to perform this study on GNSS in agriculture after some projects that we did for the GSA and DG Enterprise. The current webinar is the idea of sharing the key outcomes of a study that you can find online on our website. And it's a study, a market and technological assessment on GNSS in agriculture in 4 different world markets, EU, North America, Australia, and Brazil. So what are the macro trends in precision agriculture that we have identified? As you probably already know, the market for global navigation satellite solutions-based technologies has dramatically increased in the last decade, and this phenomenon has also impacted the agricultural sector, since GNSS-based precision agriculture allows farmers to increase efficiency of operations. Investments on GNSS-based systems can be earned back in quite a short time, thanks to the fact that operations improvements allow increasing business efficiency. And this will mostly impact time needed for operations that will be reduced. The downtime due to fog or nightfall that is also reduced. Soil compactation that is minimized by driving over precisely the same tracks. The reduced overlaps and skip that enables to save on fertilizers and also on water. And fuel consumption that is also reduced. Also, the market for agricultural machinery has dramatically changed during the last century, and it keeps evolving year after year, thanks to the continuous introduction of new technologies and solutions. So different agricultural machines are available, and they can be divided in 3 major categories, namely tractors, combines, and implements. What we are seeing right now is that different GNSS-based solutions are available for each type of agricultural machine. The second slide is also devoted to macro trends in precision agriculture, and we are seeing here the fact that end users of GNSS-based solutions for agriculture can take advantage of different types of satellite positioning technologies. And this is mostly based on a different cost-benefit evaluation that farmers will base on the type of cultivations that they focus on, their business processes, the structures of farms, and of course also the market scenarios. So in the table, in slide 2, we can see the different technologies that are available for GNSS-based solutions in agriculture and the different levels of accuracy that these technologies provide. So the highest accuracy is linked to RTK solutions, and accuracy can go up to 1-2 centimeters. Then we have commercial GNSS up to 5 centimeters. SBAS systems available in both Europe with the EGNOS system and in Northern Americas with the VAS system up to 30 centimeters. And then, of course, low-end GNSS-based technologies, the free-of-charge GPS up to less than 1 meter. And to conclude on macro trends in precision agriculture, the decision by end users to adopt GNSS-based systems, as well as the selection of different satellite positioning solutions, is taken by comparing the expected benefits that farmers will get in terms of operations efficiencies to the required investment, which of course will change based on the kind of technology and service that will be selected. The biggest difference, of course, is in terms of equipment on the one side and of eventual fees of the services on the other side. Here we find a table where on columns we can find the different technologies that are available. So starting from the left, low-end GNSS, then SBAS systems, commercial DGNSS, and then two different RTK services. RTK network, which is usually public-owned or university-owned, typically, network of RTK reference stations, and then RTK fully owned when the complete system is usually owned directly by the farmer. While on the rows, we can find the features that are usually taken into consideration while evaluating the different technologies. So, of course, the accuracy of the position, the easiness to use, the price of the device, the service fee, and the time to convergence. Here we have summarized the different level of performances based on which usually farmers will take their own decisions. Now, starting to look at the macro trends by region, as we said, we have focused on 4 different areas. We're now starting from the European region, referring to EU 27, so both Western and Eastern regions within Europe. The agricultural sector, of course, here is highly developed. There are differences between Western and Eastern regions, with Eastern regions a bit less developed, but improving very quickly. The EU represents a huge market for GNSS-based solutions. We have almost 2 million high horsepower machines and 187,000 GNSS devices that are already installed. On the graph on top, we see the evolution, the expected evolution of the penetration of GNSS over high horsepower machines in percentage. We're currently starting from 9.5%, reaching up to almost 50% in 2024. Currently, and we can see this displayed in the graph below, the most adopted technology is EGNOS, the European SBAS. This technology represents the less expensive GNSS-based solution in terms of initial investment, especially compared to the other 2 options that we see here, so commercial DGNSS and RTK. And of course, it also doesn't require end users to pay a service fee because EGNOS is provided for free. The evolution of these options, of these technology options, is towards a higher accuracy, meaning that the penetration of RTK is expected to grow from 4.5% in 2012 up to almost 25% in 2024. This will, of course, mean that this technology will erode market shares of both commercial DGNSS and SBAS, even though SBAS will still represent way more than half of the market. Moving to the following slide, still focused on the EU region, here we have a focus on the split of RTK technology between RTK networks and fully owned systems, which is represented on the graph on top of the slide. The EU region is showing a higher adoption of RTK network solutions as compared to other areas. This is mostly due to the size, the typical average size of the farms. In Europe, the average size is smaller. We're talking about, on average, 12 hectares. And this size does not justify the huge investment that is required to own base stations. So for this reason, the context has pushed for the development of RTK network solutions, especially in some areas within Europe. And we can see that already in 2012, RTK networks represented 44% of the RTK market. And they're expected to reach 75% in 2024. If we look at the sales by technology, and this is represented in the lower graph, devices and equipment prices, of course, are foreseen to show a decreasing trend. And this is mostly due to the fact that volumes are going to increase over time, and this is going to generate economies of scale, reducing prices. So what we see that we think is quite interesting is the fact that even though EGNOS market share is going to decrease in the future, the introduction and adoption of GNSS-based systems is expected to grow so fast that this will compensate the reduction in the adoption of EGNOS as compared to RTK. So what we see is a huge growth trend in RTK sales, but still also a growing trend in EGNOS sales. Now looking at the North American market, and here we're talking about USA and Canada, this area is the most technologically advanced with reference to the use of GNSS technologies for precision agriculture. And this, of course, is also linked to the specific structure of farms in this market. If we look at high horsepower tractors fleet, we're talking about 2.5 million units, while the number of GNSS devices is 450,000. So as we said, a wider market compared to Europe. In terms of penetration of GNSS over high horsepower machines, as shown by the upper graph, we're already starting with 18.4% of penetration, which is going to reach almost 60% in 2024. And the increase in operational efficiency enabled by GNSS-based solutions is particularly attractive for North American holdings, which are on average large-sized and are characterized by a capital-intensive and machine-intensive kind of approach to agriculture. The most popular technology in this market, as shown by the graph below, is represented by VAS, that is the VAS managed by the US Federal Aviation Administration, and this represents an affordable GNSS-based solution that doesn't require end users to sustain periodical service fees. So this technology today represents more than 65% of the market. But increasingly, also in North America, farmers will turn to solutions that offer higher level of accuracy. So what we see is a growing trend of RTK's market share. And this, of course, will be at the expense of DGNSS and VAS-based solutions. If we now look at the situation of RTK between networks and fully owned systems, here the situation is very different from that of Europe. The starting point is 82% of the market is represented by fully owned systems, and this perfectly makes sense with the typical structure of farms in North America that are characterized by a larger average size. So this justifies the investment by farmers in base stations of property. However, this continuous development of RTK networks that is also initially for non-agricultural purposes, such as the CORS network, is of course foreseen to progressively lead farmers to abandon fully owned systems in favor of network solutions which are more effective, require less equipment investments, and are easier to use. So in 2024, we expect RTK fully owned systems to represent only 47% of the market of RTK solutions. If we look at sales by technology, again, also in North America, prices are going to be pushed down by, of course, the increase in sales. Already, starting prices of GNSS-based solutions are generally lower than in other areas. And this, of course, will push sales. In particular, we're looking at interesting trends in RTK sales, while sales for SBAS and commercial DGNSS are going to be, we would say, stable for the upcoming years as compared to the situation in Europe. Now, looking at the situation in Australia, Australia is a very large country, but only a minority of the territory is cultivated. The agricultural sector in Australia is technologically advanced, and the GNSS-based market is well developed. This is also linked to, again, the structure, the typical structure of farms, which on average are wider than those in Europe. Currently, we have 28,000 GNSS-enabled devices that are already in use, over a population of about 157,000 high horsepower tractors. We see that the numbers here are very different from those of Europe and Northern America. In terms of penetration, we see numbers that are very similar to those of the Northern America area. In 2012, the penetration of GNSS over high horsepower machines was already 18.3%, and it is expected to reach more than 58% in 2024. Australia is not covered by any SBAS system, so for this reason, the concrete alternative to paid services such as commercial GNSS and RTK is represented by low-end GNSS-based technologies. So what today is the free of charge GPS service, now possibly integrated for some other areas, of course, by other systems, and hopefully in the future by the Galileo system. RTK technology is widely adopted in Australia. The starting point in 2012 is already 15.3%, and it is expected to reach more than 37% in 2024. So this again shows an upward trend that is linked to an increasing need of high levels of accuracy and performance by end users. We're talking about farmers. This is mostly going to impact the penetration of commercial GNSS because, of course, there's such a huge difference in terms of price between low-end GNSS solutions and RTK penetration, that the low-end GNSS solutions penetration is going to remain stable over the years. If we look at other macro trends in Australia, from a structural point of view, the vast majority of RTK systems deployed in Australia are fully owned. This is mainly due, of course, to the fact that Australia is a very large and a very large territory, and probably too high efforts are required to deploy RTK networks. So the solution, also focusing on the size of the farms, has been mostly based on owning the full system directly. Penetration of RTK fully owned is almost 90%. However, the CORS network, and we're talking about continuously operating reference stations, have been developed over the main agricultural areas. So the penetration of RTK networks is expected to grow and to reach 37% by 2024. As in other areas, prices of GNSS-based solutions are foreseen to decrease over time. And this, again, is mostly due to the fact that sales are expected to grow. Commercial GNSS sales, as shown in the graph on the bottom of the slide, are expected to mildly decrease over the next 12 years. And this market erosion is directly linked with the increasing uptake of the RTK technology that we can see is expected to be growing in the upcoming years. And finally, we look at Brazil. In the recent years, the Brazilian market for GNSS-based technology is undergoing a booming phase, even though the starting point is much lower than the areas that we have just seen. We're starting in 2012 at 5.2% penetration of GNSS over high horsepower machines. The current stock of high horsepower machines in Brazil is approximately 400,000 units. So we have more than 20,000 GNSS-enabled devices already in use. Of course, looking at the structure of farms in Brazil, these kind of solutions are mostly concentrated in the giant productive farms rather than in the small farms. And again, here Brazil is not covered by SBA, so therefore the low-end GNSS-based technologies are widely spread because of the low investment required. So these solutions are going to be the entry option for smaller farms. The penetration of GNSS is expected to grow and to reach 40% by 2024. In terms of technology penetration, as we can see, 73% of the market today is represented by low-end GNSS solutions, while RTK represents 6%. RTK is going to show an upward trend, but it's going to be a bit lower as compared to other areas. In 2024, we're expecting to still have 66% of the market represented by low-end GNSS solutions. If we look at the RTK networks versus fully owned systems, here again, we see that most of the market is represented by RTK fully owned. In 2012, 94% of the market. Of course, as we have already said, RTK networks are currently not very widespread. And this is because most of the times RTK is adopted by a very large farm and they can afford the investment required for installing their own RTK system, and also probably the geography of the country makes it quite difficult for networks to be easily developed. Still, the future the future evolution is expecting a slight uptake of RTK network solutions, which we expect to reach in 2024, 33% of RTK market. Prices are foreseen to decrease almost everywhere in the world, and service fees for commercial GNSS solutions are also expected to decrease because of the competition from RTK, which will offer a high level of accuracy and performance. So as we see here, as the market is growing so much, low-end solution sales are growing, commercial GNSS sales are growing, and RTK sales are growing. So looking at the future trends that we expect in precision agriculture, there are two different things that we would like to underline. In terms of precision farming, this context is changing quite rapidly, and as we already mentioned, new technologies are being developed and the market is growing continuously. So end users in more developed countries continue to ask for technologies that will allow farmers to further increase the efficiency of their operations and therefore save money. So it's really the needs of the farmers that are pushing the evolution of the technology. So an important emerging trend is related to the use of GNSS receivers on implements. So GNSS-based solutions are employed to support the implement in following the same guidance path of the tractors. Currently, two types of solutions are available on the market: passive and active implement guidance solutions. So this is expected to be the future trend on GNSS-based solutions in precision farming, and something we should keep an eye on. At the same time, if we look at developing countries, they're definitely looking into renovating their means of agricultural production in order mostly to face the major challenges of increasing population demanding more and more food. This is definitely one of the challenges of the upcoming decades. And in our report that, once again, I would like to remind you that you can find and download on our website, we have in particular looked at India and China. In both countries, precision agriculture is still in its infancy phase, but a booming phase might be just around the corner. Both countries are evaluating through studies the possibility to invest in precision agriculture. As of course this would allow them to increase the efficiency of the entire agricultural chain, improve water management, reduce the amount of inputs used, and optimize farming practices. In both cases, the scenario is that the agricultural sector will most probably very quickly, still we don't know when this process is going to start, but once it starts, it will very quickly switch from traditional and let's call them old economy ways of working farms to this most modern and efficient solutions. So this was the final slide. We have tried to summarize the key outputs that you can find in our much longer specific study on GNSS in agriculture. You can download the study for free from our website. Here are the contact details if you want to reach us. So very quickly,